maximum count of positive integer and negative integer. This is a really fun question to solve if you want to get into binary search. This question says, given an array num sorted in increasing order, so it's sorted, return the max between the number of positive integers and the number of negative integers. In other words, if the number of positive integers in nums is pos and the number of negative is neg, then you just return the maximum count between the positive numbers and the negative count of the negative count. So it says this was important. 0 is either negative or positive. So so 0 doesn't go towards a count of the negative numbers and the positive numbers. So if you're still new to binary search, I'd recommend solving this problem. This problem is amazing for binary search, actually. So basically, since we have this sorted array, we can binary search get the first positive integer, or first non-negative integer. So in this case, if we have a question like this, we need to find this part. Why? Finding this part enables us to get the count of the negatives, literally in log n time, right? If we find this, we can get the log n of the negatives. And then once we have this, we can actually binary search this part to get the first positive part, to get the first non-zero part. So I'll say this again. We have this array, right? We binary search to get the zero, to get the first non-negative, right? That means we can have the count of this, which is basically like this part minus this part, right? Sorry, minus this part. And then having this is a start point for a binary search, and then this is the end point. So we binary search over all of this to find this. Once we find this, then we can get the difference between all of this and this part to get this positive part, and then return the maximum between them. So this is what I did, just binary search twice, but basically first binary search is on the whole array to get okay, so we get the middle, and then every time I see nums of mid is negative, I will push the L forwards, basically. So every time I land on middle lands on this, we push the L forwards till we reach this part, of the binary search, right? Else, obviously, move the R backwards. So this is the break point, right? Where between the positives and then between non-negatives and the negatives. So this is the negative point. This is the negative count, basically. So if we found this part, right? If we found this is of index 0, 1, 2, 3. This is index 4, which is basically 1, 2, 3. Sorry, this is of index 3. My bad. Which is basically the count of the previous negative count. So we don't need to do anything, basically. That itself is the negative count. Then we will start from this part, which is the same index we just calculated, and then go to length nums minus 1 to the end of the array, and then calculate. Every time it's 0, we push it forwards. Every time we get nums of mid of 0, we just push forward, and then we'll reach a point where it would break, where it would reach somewhere like here, and then it would move the R backwards, basically. So then we need to move. That's why we do R plus 1, because it always reaches this point. The point we need, and then it's just because L is less than or equal R, so it's going to move it R backwards, so we need to correct it. But then we get the positive count, which is basically the length of the whole array minus this current index. Where is this current index at, right? Which gives us this part. And then we just return the maximum between them. So time complexity wise, it's definitely log n. Yeah, that's been it, guys. Thank you, guys, and I hope like and subscribe, I guess, and see you in the next one.